So question number 1 is an absolute value inequality problem, and notice that it's an absolute value using a greater than symbol. So the idea is this: if we have an absolute value of whatever, and it's greater than some number, say c, then we can rewrite that as the regular inequality without the absolute value bars, or, and that's important, the stuff inside the absolute value, and then you flip the symbol and you flip the sign. And basically the idea is that every single absolute value inequality problem that uses a greater than symbol will be two separate inequalities that you have to solve. So in this instance, if we have absolute value of d minus 7 is greater than or equal to 9, you were supposed to set it up as the following: d minus 7 is greater than or equal to 9, or d minus 7, flip the symbol, flip the number. And then we have two inequalities to solve. Both are solved by the same steps. Go ahead and add 7 to both sides, and you get d is greater than or equal to 16, or if we add 7 to both sides here, we get d is less than or equal to negative 2. Now the full complete answer would be this entire thing. It is a compound inequality, so you have to put the or there. That concatenates both answers together. Number 2 was an absolute value that is a less than symbol. So the idea is that if you have an absolute value problem that's less than a number, say c, the setup is you surround the stuff inside the absolute value between the positive of the number and the negative of the number using the less than symbol. So in this instance here, if we have absolute value of b plus 3 is less than 5, to set it up, you surround the b plus 3 between the 5 and the negative 5, and just solve for the variables. I'm going to subtract 3 to get b by itself, but you would have to subtract 3 from all three sides. So it's negative 8 less than b, which is less than 2. So that would have been the complete answer. Number 3 was just a simple linear equation. Hopefully nothing too strange about this one. The idea is that to solve an equation, you want to get all the variables on one side and all the constants, the regular numbers, on the other. So I'll go ahead and add 3w to both sides, giving us 4w plus 9 equals 2. So we got to get rid of that 9 by subtracting 9 from both sides, giving us 4w equals negative 7. And then, of course, the last step is to divide up the 4. W equals negative 7 over 4. 4 does not divide into negative 7 evenly, so you leave it as a fraction. Number 4 was just another example of solving an equation. One of my hints was if you have some complicated things like parentheses, to simplify the problem before actually solving it. So typically numbers in front of parentheses tells you to distribute. Do note it's a minus, so you're going to be distributing the negative as well. So this is 5n minus 4 plus 2n, because I'm multiplying by negative 2, equals negative 7. We'll go ahead and combine like terms, so that's 7n minus 4 equals negative 7, and then it becomes a two-step linear equation. Let's add 4 to both sides. 7n equals negative 3, and then of course divide up the 7. So you get n equals negative 3 sevenths. Number 5 was just more practice of the same thing, so it's just like questions 1, 2, 3, and 4. So this is an example of an equation with variables on both sides, and again, we've already addressed it. The technique is to get the variables on one side and the regular numbers on the other. So in this case, I'm going to subtract 6z from both sides. That's not the only option you can do, but I like to keep the variable positive. So that's 3 equals 2z minus 5. And then we'll go ahead and add 5 to both sides. So you get 8 equals 2z, and then divide out the 2, you get 4 equals z. Question 6, more of the same thing. It's just the problems are getting slightly larger, but the idea is still the same. You want to simplify both sides first before you dive into the solving. So on the left-hand side, I can go ahead and combine like terms, and on the right-hand side, I can go ahead and distribute this negative. So that will give me 3x plus 14 on the left equals 9 minus 4x minus 2 after I distribute. I'll go ahead and combine like terms on the right-hand side. I'm not going to do anything to the left-hand side, so I'm just going to copy them down. Always copy down the parts of the problem that you're not going to do anything with. And then when I combine the 9 with the minus 2, that gives me a positive 7. And I didn't do anything with the minus 4, so copy it down. Notice it's just like problem 5, where you have variables on both sides. So get all the variables on one side, get all the constants on the other. Since I like to keep the x's positive, I will add 4x to both sides. So that's 7x plus 14 equals 7. And then hopefully it becomes a little bit automatic from here on out. Subtract the 14. 7x equals negative 7. Divide the 7. You get x equals negative 1. Unit 1 was all about solving equations, so not surprisingly there are a lot of equations on this exam. So this one here, I notice I have a parentheses, so that usually tells me to distribute. So you have 5n minus 2n plus 4 equals negative 1. Let's go ahead and combine like terms. 3n plus 4 equals negative 1. Subtract the 4. 3n equals negative 5. Divide out the 3. n equals negative 5/3. What do you know? More solving. Negative 3x plus 5 equals 7x plus 8. Get the variables on one side, get all the numbers on the other. That's basically the mantra for linear equations. Since I like to keep the x positive, I'm going to go ahead and add 3x to both sides. Now let's see if we can do two steps at once, and then I'm going to, at the same time, subtract 8 from both sides. So what that's going to give me is a negative 3 equals 10x. And then hopefully we can see that we just divide out the 10 to give us x equals negative 3/10. Yeah. Finally, something new, absolute value equations. So the idea is that when you have absolute value equations, that if you have absolute value of stuff equaling whatever, I'll use the letter C to denote whatever we have here. The idea is this: you're going to set up two equations. This, you just do the regular without absolute values, and then what you're going to do is you're going to take the opposite of whatever's inside the absolute value and set it equal to the other side. So in this particular instance here, we have absolute value 3x minus 4, so I'm just going to rewrite it without the bars. Absolute value 3x minus 4 equals x minus 8, and then I'm going to do the exact opposite of 3x minus 4 equaling x minus 8, and then notice we have two equations in which we will go ahead and solve independently. I won't go into great detail about how to solve linear equations. I'm assuming after going through problems 1 through 8, we're sort of good with it. So if you need assistance with solving linear equations, go ahead and watch the problems for questions 1 through 8. So for the left equation here, so for this equation we'll work with first, I'm going to subtract the x and add the 4. So that gives me 2x equals negative 4, so x equals negative 2. I guess I should probably write it. In this instance here, some people can distribute the negative. I like to divide out the negative 1. It's completely up to you. And I know when I divide out a negative 1, all it does is it flips all the signs on the right hand side. So that's a negative x plus 8. And then again, I'm going to do two steps. I'm going to add the x, and then I'm going to add the 4. So that gives us 4x equals 12. Divide out the 4, x equals 3. Now notice how the original problem an absolute value problem had x's or variables on both sides. Every single time you have an absolute value problem that has variables on both sides, you must check your answer, because we may get extraneous solutions. So let's check -2. All you got to do is plug in a -2 into the original problem wherever you see an x. So I'm just going to copy down the problem, absolute value of 3x minus 4 equals x minus 8, but wherever I see an x, I'm going to substitute a -2. So instead of x minus 8, it'll be -2 minus 8. And then you just go ahead and do the math. So 3 times -2 minus 4 is a -6 minus 4 is absolute value -10 equals -10. And I know that the left-hand side here, this will give me a positive 10. And of course, the absolute value does not equal a negative. So this is wrong. So we have to throw away this answer. To check x equals 3, we'll do the same thing. Just plug into the original problem. Wherever I see an x, I'm going to substitute a 3 in. So all I'm doing is just copying the original problem, but wherever I see an x, I'm going to toss in a 3 here. Yeah, that was the original problem. And then you do your math. Absolute value of 3 times 3 minus 4 is absolute value of 5, and that equals, on the right-hand side, -5, which I know is a false statement. So this guy here is bad. I've tested all of my possible answers. None of them work. I don't have any other answers to check. So this problem here, problem number 9, I ran out of questions, I ran out of answers to test, is no solution. All right. Number 10 will follow the same suit because it's an absolute value problem with variables on both sides. So I won't go through the spiel here. So you set this up as the original, and then the opposite, and then you go ahead and solve the two problems. Here I'll subtract x from both sides. I suppose for the sake of this video I'll go ahead and show my work, and then divide up the 3. X equals a third. Here I'll go ahead and divide up the -1. X plus 1 equals -4x. I'll go ahead and subtract the x. 1 equals -5x, excuse me. And then go ahead and divide out the -5. Gives me x equals -1/5. As always, you're going to have to check your answers. So you're going to check your answers by plugging the potential solutions into the original problem. I'm not going to show it in this video. You can do it yourself. But let me just fast forward. If you're going to check, this answer is good, this answer is bad. So you only have one answer for number 10, 1/3. Number 11, some key ideas. You and 5 friends. Oh, let me make that smaller here. You and 5 friends. So that means there's 6 people. The tickets cost $4.50 each. You each buy a drink for $2.25, and you each buy popcorn for $3.25. So every single person is going to spend $4.50, $2.25, and $3.25. So there's 6 of each of those. So the total amount you spent is each 6 of you will spend $4.50 plus $2.25 plus $3.25. You either use mental math, or you go ahead and grab a calculator. What's that? That's $4.50 plus $2.25 is $6.75 plus $3.25 is what's that? $10. So you all spent $60. Hopefully number 12 wasn't too crazy. It's just combining like terms. Negative 9f plus 2 minus 9f minus 9. So your like terms are your f terms. And your constant are your regular number terms. So negative 9f plus negative 9f is negative 18f. positive 2 with the negative 9 is a negative 7. Same thing with number 13, it's just combining like terms, but the idea is if you see parentheses, it usually means distribution. So for the first parentheses, you can distribute a 4. That gives you a 4b plus 1. For the second parentheses, you can distribute a negative. That's negative b minus 1. And then you can go ahead and combine like terms. You can combine the b's and combine the constants here. So notice that the yellow, 4b with a negative b, is 3b's. And then the blue, positive 1 with the negative 1, they all cancel out. Oh, sorry, I lied. Haha, this is wrong. I can't distribute. 4 times 1 is a 4. Plus 4 here. So let's do that over again. The yellow, 4b with the negative b is a 3b. And the blue, positive 4 with the negative 1, is a positive 3. Number 14, a rectangle. I'm not gonna even read the whole thing. They give me a rectangle, so I'm gonna go ahead and draw a rectangle here. So a rectangle is 5 feet longer than it is wide. So the only information they gave me was a comparison. One thing is 5 feet longer than the other. But other than that comparison, we really don't have any other information. So I'm going to have to use a variable. Well, since I'm comparing it to its width, it's 5 feet longer than it is wide. So the width is sort of like the thing that's controlling the problem. I'm going to make the width my variable. And I know that its length is 5 feet longer than that. Well, to be longer than something is addition. So I know the width is, the length is the width plus 5 feet. Then it says the perimeter is 34 feet, and we have to know that the perimeter of any polygon is the sum of all the sides. So I should know that this is also the width, and the length is also the width plus 5 feet. So it says the perimeter, adding up all the sides, if I add w plus 5 plus w plus 5, all I did was I took this guy plus this guy plus this guy plus this guy. That's the perimeter, and according to the problem, the perimeter should be 34. And then you just go ahead and combine like terms and solve it. So you have 1, 2, 3, 4 w's plus a 5, and a 5 is a 10, equaling 34. It gives you a linear equation to solve. Subtract the 10, divide out the 4. The width is 6 feet. What does the question actually ask us? It asks us for the length. So we found the width, which is not what they wanted us to know. But what did they say originally? The length is 5 feet longer than its width. So if width is 6, then the length is 6 plus 5 feet. It's 5 feet longer, which is 11 feet. Number 15 is just more solving equations. We did this in questions 1 through 7 or 8, so I'm not going to spend a lot of time explaining this. So let's add 9 to both sides. That's what, 81. Divide out the negative 3. 81 over negative 3, which should go in evenly, which is what, negative 27, negative 27. 16, more solving equations. Man, this whole test is basically solving equations. I'm going to subtract the 9 over, and then to get rid of the denominator of 8, you got to multiply by 8. That's it. 1 times 8 is 8, of course. Here, for problem number 17, it was one of you either know it or you don't know it. I mean, there's nothing to figure out. You just have to be able to recognize the properties. I notice that if this was the original statement, yeah, it looks like the order was changed, but if you notice that the grouping itself wasn't changed. What's inside the parentheses is 5 plus 7. So I know it's not associative, because associative would mean that the parentheses are different. So all I did was I moved the parentheses to the front. I moved things. That is the commutative property. When you move terms, it's the commutative property. And since we're doing addition, it's a commutative property of addition. If you just put commutative property, I gave you full points. But again, there's nothing to solve. You just have to know it, or you don't know it. Number 18, a word problem. A person is able to burn 7 calories per minute on an exercise bike. So I know for the bike, it's going to be 7 calories per minute. So I'm just reading the problem here. 10 calories per minute in a rowing machine. So for rowing, it's 10 calories per minute. A person spends a total of 1 hour exercising. So that's what it says here, 1 hour. So notice how it gave us a total time 1 hour, but these guys here are in minutes. So I'm going to convert the 1 hour into 60 minutes. So I know that the total time is 60 minutes, or 1 hour. And we burn a total of 525 calories. So total calories is 525. How long did we spend riding the exercise bike? And when it comes to word problems, it's sort of logic. Typically, when you set up equations, you're going to put your totals at the very end. So it's usually going to be like total equals. So the totals they give me is calories and time. Now, the purpose or the main idea of this word problem is burning calories. So it makes sense that we're going to focus on the calories. 525 equals. And where did the 525 come from? It came from burning the calories. Well, how much or how many calories do we burn? That's these pieces of information. So we're burning 7 calories per minute of riding the bike. I don't know how long I ride the bike for, so that's the job of a variable. If I use x, I'm going to let x equals the number of minutes on the bike. But biking isn't the only thing we did. We also rode, and if we row, we burn 10 calories per minute. Well, how long did we row? We don't know. So we could use a variable, but they did tell us that we spent 60 minutes total. We've already declared that x is the number of minutes on the bike. Well, if we spent 60 minutes total, and we're only rowing and we're only biking, well then, if x of those minutes is biking, then the leftover minutes, or in other words, 60 minus x, should be rowing. This is the equation that we're solving. So just go ahead and solve that guy like a regular linear equation. I'm going to distribute the 10. So that's 600 minus 10x. Combine like terms. So that's 525 equals the like terms are here. 600 minus 3x. Subtract the 600, that's negative 75 equals negative 3x. Divide out the negative 3, and you get x equals 25. So 25 minutes is how long we spend on the bike. Number 19 is solving the equation, but we have multiple variables. Lots of different ways to solve this. I'm going to attempt to solve it in a way that most people would solve it. It may not be the way I solve it, but I think it's the way that most people would. So the first thing I notice is stuff out in front of parentheses. That usually tells you to distribute. So that's 3/5 a minus, and if you need work on 3/5 minus 10, I mean, we have a calculator for you, so that's all I'm going to do here when I distribute to the minus 10. 3/5 times 10 is just negative 6. And then I'm solving for a, so I'm going to get a by itself. So I'm going to add 6 to both sides. And then to get rid of the 3/5 in front of the a, you divide by 3/5. But of course, we should know that dividing by a fraction is the same thing as multiplying by the reciprocal. And this technically is the solution because a is by itself. If you went ahead and distributed the 5/3, that would have been perfect as well. So that would give you a equals 5/3 b plus 10. Either way is fine. More straightforward solving equations. This should be automatic by now. Let's add 8 to both sides. 4u equals 16, and divide out the 4 gives you u equals 4. That was pretty simple. Solving inequalities, it's the same idea as solving equations, with the only caveat: if you multiply or divide by a negative, you must reverse the inequality. That's why I always try to keep my variables positive, because if I keep the variable positive, I sort of prevent this situation from happening. So let's take a look at this example, number 21. 3d minus 12 less than or equal to 11d minus 4. I like to keep the variable positive, so I'm going to go ahead and subtract the 3d over. And hopefully at the same time we can go ahead and add the 4 over. The reason why I'm doing that, of course, is by subtracting the 3d over, I've declared the variable will be on the right hand side, so we're going to go ahead and move both constants to the left. This gives us negative 8 less than or equal to 8d. Divide both sides by 8. You get negative 1 is less than or equal to d. I typically like to write my answers with the variable first, so I probably would have written as d is greater than or equal to negative 1, but I would have accepted both answers. Number 22, solving an equation for a different variable. The only reason why this is, quote, hard is I toss in some fractions, but the idea should be the same. If I'm solving for y, it's as if I'm highlighting the y here. So let's see if I can use the yellow. Oh, close enough. It's as if I'm highlighting the y here. So that means I need, in this particular problem, I need to get rid of the x, I need to get rid of the 1/2. In math, you typically get rid of things that are farthest away first. So x is farther away from the highlighted y, so I'm going to subtract x from both sides. That's 1/2 y equals negative x minus 1/3. And hopefully we know that to get rid of a 1/2 coefficient, you multiply by the reciprocal, which in this case is 2. So 2 times 1/2 cancel, gives us a single y equals, and if we distribute the 2, it gives us negative 2x minus 2/3. This one, this word problem, if you had no idea what to do, if you looked at the units, it probably would have helped you figure it out. So here, how long does it take to travel 150 miles? So that's obviously miles. Average speed of 60 miles per hour. So that's obviously miles per hour. And what is it asking you? So my question is, the actual question is how long. Now, in terms of units, we have miles and miles per hour. If I ask you how long, I hope you understand it's asking for a time. And in this particular problem, the unit of time is hours. So what you're asking yourself is, can I put these units together to make a true statement? I hope it's sort of like no-duh common sense that to get miles per hour, you take the miles and divide it by the hours. Well, then we can think of the numbers. The miles they gave us was 150. The miles per hour was 60. It's asking us to solve for time, so I don't know what that is. So that's my variable t. And then you just use logic. Miles per hour equals miles per hour. So 150 over time equals 60. And then hopefully this should be a simple equation to solve. Let's multiply both sides by t to get rid of the denominator. 150 equals 60t, and then divide up the 60. So you get 150 over 60 equals t, and then you can reduce that as much as possible. We can cancel out a 0. We can divide out a 3. It gives us 5/2 equals t. time, again, was in hours. So it's 5 halves hours, which is 2.5 hours. Right? Either way, I would have accepted. 24 is probably the most missed question. It gives us a formula here, and it asks us to solve for h. S equals 2LW plus 2LH plus 2WH. This is a question I curved out, but if you're interested in how to solve it, this is how you solve it. I'm solving for h, so I sort of like visualize where h is. So here's the h here, which means this guy does not have an h, so I don't really care for him, so we're going to get rid of him by subtraction. So we get s minus 2lw equals 2lh plus 2wh. I hope we can see that both of these guys here contain the h I want. So we're going to go ahead and factor out the greatest common factor, which is the h there. And then notice when we do that, we have one term of h now. This is the h that I want, which means this stuff here I want to get rid of. Well, that parenthesis is trying to multiply, so to get rid of it, we will divide. That's all you had to do for number 24. And that is the solution. Because there's no like terms, so just leave it separate. S minus 2lw over 2l plus 2w is the h by itself, as we want. Number 25, evaluation. I give you an expression, but I give you numbers for them, so all you got to do, just plug it in. My advice was every single time you substitute, use parentheses. So the G will be yellow, the H will be blue. So if I have 3G plus 4H, I have 3G was yellow plus 4H was blue. Wherever I see a yellow, put parentheses 5. Wherever I see a blue, put parentheses -3. And then all you gotta do is just do mental math, or if you need to, use a calculator. That's 15 minus 12, which is 3. Number 28, same thing, evaluation. Remember, when you substitute, use parentheses. In this case, wherever I see an A, I'm going to put a parentheses -3. 2a cubed plus parentheses 2a cubed. Again, wherever I see an A, wherever I see in yellow, I'm going to put parentheses -3. So copy the problem. 2, instead of A, put parentheses -3. Cubed plus parentheses 2. I see an A, so I'm going to put a parentheses -3. Close the parentheses cube. And then just use arithmetic, order of operations. On the left here, -3 cubed is -27. Inside the parentheses is a -6. And then do math. -27 times 2 is a -54. Plus -6 cubed is -216. And then you go ahead and add those guys together. Gives you -270. (27) is a property problem. Again, you either know it or you don't know it. One thing we should note is we have parentheses. And what do you notice about the parentheses? The stuff inside of them are different. Notice the order of the term, or the order of the factors are the same. You got 3, 5, 7, 3, 5, 7. The only thing that's different is I grouped different things. I associated different things together. So this is the associative property. If you want to get fancy, since they're all multiplication, it's the associative property of multiplication. But if you just put associative property, I give you credit. Number 28 looks like it's a lot of info. 5 friends. They want to buy 3 salads. Let's see if I can color code this. 3 salads, 5 sandwiches, 2 bowls of soup, 1 large drink, I'm running out of colors, and 4 medium drinks. Well, we have the medium drinks here, we have the large drink here, we have the bowl of soup here, we have the sandwiches here, and we have the salads here. Probably should. There we go. We have the salads here. So all I gotta do is basically, put the numbers together. So we have 3 salads at $1.50 each, plus 5 sandwiches. 5 sandwiches at $3.50 each, plus 2 bowls of soup at $2.25 each, plus 1 large drink at $1.05, plus, geez, I forgot the color I used. I think it was this color, plus 4 medium drinks. So plus 4, and the medium drinks are 90 cents, 0.95. So then you just go ahead and whip out a calculator and figure out what that guy is. I suppose I should have a calculator handy. Give me a second. So 3 times $1.50 plus 5 times $3.50 plus 2 times 2 1/4 plus $1.05 plus $4, or excuse me, 4 times 95 cents, which gives us a grand total of $31.35. However, the question, this is the actual question. Find the costs each person will owe. So you're splitting the check evenly. There are 5 friends. So the answer is the total that we found divided by the 5 friends. So if that's the grand total divided by 5 friends, is $6.27. 29 is the evaluation problem. Wherever you see an X, put a -2. Wherever you see a Y, put a -1. So 4X plus 6Y. Again, X is the yellows, Y is the blue. Wherever I see those letters, I substitute the numbers with parentheses. So instead of X, put a -2. Instead of Y, put a 1. And then you just do math. More evaluation. Wherever you see an X, put a 1/6. Wherever you see a Y, put a 3. So that's 7 plus 5. And this, no, actually it does have X's. 5Y divided by 3X. So here's the X here. Here's the Y. So that's 7 plus 5. Instead of Y, put a 3. Instead of X, put a 6. Order of operations, use the parentheses first. I'm going to do this part first. So that's 7 plus 15. 7 plus 15 is 22. 3 times a 6 is a half. Divided by a fraction is multiplying by the reciprocal. Number 31, more solving equations. Hopefully by now we are super duper experts at this. First thing I'm going to do before I do any solving is to simplify. So I'm going to go ahead and distribute the 4, and we'll go ahead and distribute the negative. So this gives us 8x minus 12 equals 6 minus 3 plus 2x. I'll go ahead and combine like terms. 8x minus 12 equals 3 plus 2x. And then hopefully we can do 2 steps at once. Subtract the 2x over. And at the same time, let's add the 12 over. Giving us 6x equals 15. X equals 15 over 6, which always reduces. Not a lot of people reduced on their tests. Try to reduce your fractions as much as possible. More evaluations. Wherever you see a z, change it to a -2. So 42 minus z over -2z plus 4. I see z's here and here. Use parentheses whenever you substitute. So that's 42 minus, notice I use parentheses when I substitute, negative 2 times negative 2 plus 4. Do math. In the numerator, a negative makes a positive, so that's 42 plus 2 over negative times a negative is a positive. So negative 2 times 2 is a 4, and then 44 over 8, which reduces to 11 halves. Here, you're saving money to buy a new basketball that costs $52. So that's the total cost, and you have 34 saved. So if it costs $52, you already have 34 saved. How much more money do you need to save? Well, that's simple. If I have 34 saved, I'm going to save more. That's addition. That's the equation that you need to set up. But remember, in a word problem, each number and letter has a meaning. So this is the total cost. This is already saved. This is need to save. And if you look at the choices, let's see here, total costs, already saved, need to save, you can pinpoint them fairly quickly. Let's see here. Total cost, let's see, was 52. Where does it say that? Cost is 52 right here. $34 was already saved. Where does it say that? Amount saved is $34. Need to save is X. Where does that say that? Amount to save is X. So even if you didn't know how to solve it by process elimination, the choice is A, because that's where all the information is. 34, solving for letters when there's lots of letters in a problem. Remember, when I do solve an equation, I like to pretend that the variable I'm solving for is highlighted. So notice how this is a variable on both sides problem. I got n's on both sides. So the general concept is move the variables that you want on one side and move the unwanted stuff to the other. So we're going to add n's to both sides, and hopefully at the same time we can subtract the m's. This gives us negative 7m, these guys are gone, equals, these guys are gone, 8n, so divide out the 8, n is negative 7m over 8. Last but not least, word problem. Literature Club is printing a storybook to raise money. The print shop charges $5 for each book. So anytime in a word problem that there's a recurring thing, it changes this amount every single time. You pay this for every single item. That number, in this case 5, is usually going to be attached with the variable. Now in this case here, it's each book, so x equals the number of books, and a one-time fee of $80. So anytime there's a singular fee, you only pay it once. It doesn't happen over and over and over again. It will not be attached to a variable. So this $80 is on its own. So the question says, how many books can the club print if their budget is $1,155? So if this is the total cost, well, that's going to equal my budget. And notice it gives me an equation that we can hopefully solve. So we're going to go ahead and subtract 80 from both sides. That's supposed to be 5. And then we'll go ahead and divide by 5, which gives you 215, which is choice D.